Here we've got 6.2, using the normal distribution. In the last section, we already kind of defined the normal random variable x, so just a little refresher. A normal random variable is uniquely defined by the mean, mu, and sigma, or standard sigma, the standard deviation. So we can write that as x being normal with mu and sigma being what defines it. Symmetric about the mean, mu, and then that shape, how spread out that the curve is, and how tall or short it is determined by the standard deviation. Total area under the curve is 1, and to find probabilities that x, the random variable x, is in between two values, we find the area under the curve between those two values. All right. So we're going to use the standard normal to find exact probabilities when the empirical rule does not apply. Last time we were able to estimate probabilities or get approximate probabilities, but sometimes we want exact probabilities. So to do that, it can be helpful to start with drawing a picture of the normal curve, label the probability that you want to find, that we want to find. And then the second thing is to convert the boundaries of the shaded area to z-scores, all right, using this relationship between x and z. And then we're going to use the online standard normal calculator that I have a short introduction to posted as well. Okay, so we're going to start by assuming that we already have z calculated. So we're actually going to just jump to doing number 3 to start off with. So we want to find the probability that z is less than 1.5. So if we label our density curve, we assume this is z, and we have a mean here of 0. And if we think of the marks along the horizontal as marking off z values, or another way to put that, z scores, then the 1.5 is going to be right here. And if we shade the probability, the area, okay, we're going to shade all the area to the left of 1.5 underneath the density curve. And that area is going to be that probability. So okay, so here's where we use that online calculator, or if you have some other tool to use, if you've got a graphing calculator, you can use that to find probabilities. I'm going to be referring to the way that the calculator that I have posted is set up. So we're going to go to that calculator where you're going to plug in 1.5 as the value, and then we want to the left of that. Okay, so plugging that in, we're going to get a value for probability of 0.9332. Okay, let's look at this one. Now we're looking for the probability that z is between 0 and 1. So in probability notation, we have that there. So there's the 0, all right, the 1.5 is right there. So this time we're not going all the way to the left, right? We're just going between 0 and 1.5. So that's the area that we're looking for. This isn't given directly in as an option in that online calculator, all right, but if we remember that to the left of 0, that area under the curve is going to be equal to, hopefully you're thinking of what it is half the total probability of 1, so that's 0.5. All right, so we found that the probability that z is less than 1.5, in the previous one we found was 0.9332. So now we don't want the area that's to the left of 0, so we can subtract that off. So we subtract that 0.5 and we get probability of 0.4332. Okay, let's look at this one. Here's a greater than probability. So again, we set up our 0 here, and then 0.85 is going to be somewhere just left of just left of where the first standard deviation is. And here we want greater than, so we're going to shade the under the curve to the right. Okay, so we just need to select the correct option on the online tool, plug in that 0.85, and we get 0.1977. Okay, let's look at this next one. Z is between negative 2.1 and positive 2.1. So negative 2.1 right here, and positive 2.1 right here. And we want all the area in between. All right, so this online tool makes this really easy for us. We just plug that in, we get 0.9643. Okay, let's try this one. We've got probability that Z is greater than negative 2.13. So there's our negative 2.13. So greater than that, it's going to be everything to the right. Okay, just plug in the negative 2.13 and select the correct option, and we're going to get 0.9834. All right, less than negative 1.89. All right, so maybe something about right there. And we just want this little piece right here that is in the tail. And we want to select the first option for it to be less than to the left of that value, and we get 0.0294. Okay, Z is less than negative 1.28. Or greater than positive 1.28. So here's where we've got area shaded in the left tail and in the right tail. All right, we have one of those as an option in the online tool, and that area is 0.2005. Let's look at this next one. We want the probability the Z is between negative 0.75 and positive 1.03. So sketching that on the curve, there's our negative 0.75 and the positive 1.03. We want the area in between those two values under the curve. This isn't going to come directly from any of those options on our online tool. So let's think about what we have though. If we look at just the piece of the curve that is just to the left of 1.03, we can find that probability. So the probability that Z is less than 1.03. And then that's going to include this piece here, which we don't want, right? We want to get rid of that. So we're going to subtract that. Well, that's the probability that Z is less than negative 0.75. Okay, so plugging both of those things into the online tool, both those values for Z, we get 0.8485 for the probability that Z is less than 1.03, and we're going to subtract from that 0.2266, the probability that Z is less than negative 0.75. So we end up with probability of 0.6219. Let's look at this next part. 75% of Z values are less than what Z-score. So this is one for which we have a probability, but we don't know the Z value. So if we got our 0 is right there, and there's some value, we'll call it, let's just call it, say, K, that less than it are 75% of the values. So here we know the area is 0.75, but we don't know what that value of K is. We can write down the probability statement though. The probability that Z is less than K is equal to 0.75. So this is what we'll use that arrow going the other direction for. We'll plug in 0.75 for the probability, and click the arrow, and we end up with that k value being 0.67. We can just round to 2 decimal places since it's a z-score. Okay, now let's move on to this next example where we're not starting out already with a z-value. So suppose final exam scores for a statistics class are normally distributed with a mean score of 70 and a standard deviation of 6. Find the probabilities. So let's start off by defining this random variable. We're going to assume that x is, we're told that it's normal, and it is defined by the mean being 70 and the standard deviation being 6. So if we put this on the density curve, okay, in the middle here we've got 70. We're also going to think about having another horizontal axis, which is representing z values. So first thing we want to do after getting the picture going, we want to convert the value of x into a z value. So the probability that we're looking for is the probability that x is greater than, or sorry, that x is less than 60. So we've got to find the z-score. Let's do that down here. So z is equal to 60 minus 70 over 6. And so we're going to get negative 10 over 6, which is a negative 1.67, rounding to 2 decimal places. So this probability about x is going to be comparable to this probability about z, that z is less than negative 1.67. Okay, so on the z-scale, all right, we can put that negative 1.67 right there, which means that's where the 60 shows up on the x-axis, and we want the area to the left of that. Okay, so here's where we go to that online tool and plug in negative 1.67 and find probability of 0.0475. Okay, let's find the probability that x is greater than 73. So we're finding probability x greater than 73. So find the z-score. Let's take 73 minus 70 over 6, and that gives us a z-score of 0.5. Okay, so if we just look at this density curve being for x, then 0.5 for z, or 73 is going to be about right there. Okay, and we want greater than this value, so our shaded area is to the right. So using the online tool, you can find the probability that z is greater than 0.5, and that will be 0.3085. Okay. Okay, let's look at probability that x is greater than 65. So finding the z-score. 65 minus 70 over 6, that'll be a negative 0.83. So on the density curve, that just tells us 65 is going to be about right there. So the probability that we're looking for is the area shaded to the left of 65. So we rewrite the probability statement as the probability that z is greater than negative 0.83. And from our online tool, we get 0.7967 for that probability. Okay, let's look at the probability that x is between 75 and 80. So exam scores are between 75 and 80. The probability statement, probability 75 less than x less than 85. right, we have two z-scores to calculate. 75 minus 70 over 6, which is 0.83. And 85 minus 70 over 6, which is 2.5. Okay, so putting this on the density curve, there's the about where 75 is, and then 85 is going to be about there. And we want this area in between. Okay, so this is one where we're going to have to find two probabilities. We're going to find the probability that x is less than 85 and then subtract the probability that x is less than 75. All right, but we're going to do this with the z values, so we want the probability that z is less than 2.5, and then subtract the probability that z is less than 0.83. Okay, so from the online tool, we find that probability that it's less than 0.9938, and the probability that z is less than 0.83 is 0.7967. And doing the subtraction, we get the probability of 0.1971. Let's look at this one. 80% of the exam scores are less than what score? Okay, so if we have our x's here, our 70 goes there. Let's put our z-axis. You know, that's 0. All right, so we're going to first find the z-score that gives us 80% to the left. So we'll say that that's going to be about right there. And then we're going to want to find this value, let's just call it k, such that this area to the left is 0.8. So the probability statement that we're looking at is the probability that z is less than k is equal to 0.8. So here's where we're going to go and do the reverse thing on our online tool. We'll plug in the 0.8 to probability and then select the correct area shading, and then find the value for z. And what we find is that z is equal to 0.84. Okay, so that's the z value for which 80% of the values are less than. We want to find the x value, so using our relationship between x and z, we know that z is 0.84. That's equal to, we're looking for this exam score x. Subtract 70, divide by 6, and then solve for that x. So multiply both sides by 6, add 70. That gives us the exam score of 74.4. So we can say that 80% of the exam scores are less than 74.4. All right, let's look at this next one. 5% of exam scores are more than what score? Okay, so using finding the z value that has 5% of the exam scores above it. All right, we're going to be looking at something up here and looking for that shading. So we're looking for this value k. So we got the probability that z is greater than k is equal to 0.05. So we're going to select a different one of those distributions. We want the one that has the area to the right, and plug in that probability of 0.05, and we're going to get that z value, or that k is going to be equal to 1.645. And then solving for x, plug in 1.645 equals x, that unknown exam score, and then multiplying by 6 adds 70. It turns out that exam score is rounding to one decimal place, 79.9. So 5% of the exam scores are above 79.9. Okay, here is one more example. If you haven't done this already, I would suggest pausing, working through this on your own, and then looking at it worked through. So let's start off by defining the random variable. We've got x is the percent of fat calories, and we're told that those are normally distributed. So x is normal with a mean of 36 and standard deviation of 10. And we're looking for the probability that x is between 38 and 50. So we put that on the density curve. I don't know exactly where 38 is. Let's just estimate it's about right there, and then estimate 50 is right there. So this is the area, or the probability that we're looking for. Okay, we want to convert those values of x to z-scores. So we'll take the 38, subtract 36, divide by 10. That gives us a z-score of 0.2, and for the 50, we get a z-score of 1.4. Okay, so this probability we can write as the probability that z is between 0.2 and 1.4. Okay, that's not an option given to us in on the online tool. So we need to first find the probability that x is less than 50 or z is less than 1.4. Okay, and that will give us the area to the left of 1.4 or 50. And then we want to subtract off the area that we don't want, which is going to be the area to the left of 38. So probability that z is less than 38, or the z-score of 0.2. All right, from the online tool, we have probability that z is less than 140 is 0.9192. Probability that z is less than 0.2 is 0.5793. And doing that subtraction, we get 0.3399. Okay, let's look at this one. We're wanting the probability that x is between 19 and 24. All right, so 19, we can put that somewhere like about right there, and the 24 go there and there. So we're looking for that area right there. Okay, so converting to z-scores. All right, we get a z-score of, for 19, we get a z-score of negative 1.7, and for 24, all right, we get a negative 1.2. So this is a probability that z is between negative 1.7 and negative 1.2. All right, so again, we need to find the probability that x is less than 24, or the probability that z is less than negative 1.2, and then subtract off the probability that x is less than 19, or z is less than negative 1.7. All right, so from is 0.1151, and the probability that z is less than negative 1.7 is 0.0496. So doing that subtraction, we get the probability of 0.0655. Let's look at this one. 10% of Americans consume less than what percent of fat calories? So labeling our density curve, 10% Americans consume less than what percent? So 10% is a small amount. We're wanting some value that 10% is less than. So, that's going to be, over here somewhere. So we're looking for that unknown value of x. So the probability statement that we're looking at in terms of z is the probability that z is less than k is equal to 0.1. Okay, so going backwards in that online tool, right, we find that value is negative 1.282. And we actually want x. We want the percentage of fat calories. So plugging that in for z, and then we solve for that unknown value of x. And we get x is equal to 23.18. If we round to one decimal place, we get 2. So 23.2%. So 10% of Americans consume less than 23.2% of fat calories. Okay, that's it for 6.2.